Coś śmiesznego powiem.
My name is Thomas. I was born in 1946, and I am 75 years old.
And my wife is falling asleep right there. As you have noticed, each sentence in English or in any other language, whether it's Polish, German, or any other language that you might speak, has a structure. And the words in that structure can be classified into verbs, nouns, adjectives, pronouns, proverbs, anything. We as human beings like to classify based on a well-known pattern. Or if there is a definition of a group of objects, then we like to put new objects into those groups. And that's exactly what we are doing here in R. We have talked about vectors, matrices, and data frames in the previous episode. In this episode, we will talk about data types. What type of data is in my vector? What type of data is in my matrix? What types of data are in my data?
These are the most popular data types in R: character, numeric, date, factor, and logical.
Vectors have only one dimension, and they also have only one data type. A vector can be either numeric, or a character, or a factor, or a date, or any other data type that we had mentioned before. A matrix also has only one data type, numeric. However, if we go into data frames, to the most ultimate R objects, we can see that variables can be grouped into different data types. I can have one full data frame with different variables, and these variables can be classified into different data types. The first variable, for example, could be numeric. The second one could be a date. The third one could be character. The fourth one could be a character converted to a factor, and we'll talk about that a little bit later.
Let's go to RStudio and let's create a few vectors that are numeric, a few that are character, and maybe a few dates. Let's do it. I'm going to start with creating a vector with my roommates' names. I'm going to call it names. Reverse arrow. I'm going to use the C function. In the C function, I'm going to provide 4 names of my 4 roommates. Carolina, comma, Zoe, comma, Cindy, comma, John. 4 roommates. All right, and I'm going to click Command Enter or Control Return, and it's going to save these in my environment called names. We'll have 4 names as a character vector: Carolina, Zoe, Cindy, and John. What I will do now is create 4 numerical vectors with salaries of my roommates. The first numerical vector will be for Carolina. We will simply call it Carolina underscore sal. That stands for salary. Put the reverse arrow. And the C function. In the C function, I will provide 4 different salaries for 4 different years. And Carolina might be a software engineer, so she will make $101,000 in the first year, and then $90,500 in the second year because she didn't get her bonus, and $120,000 in the third year because she got a big bonus, maybe $89,000 in her fourth year because she changed her job, right? So 4 salaries for 4 years just for Carolina. Now a second vector for Zoe. We'll call it Zoe underscore sal. That's the name of our new vector. Reverse arrow, C function, and we'll provide 4 numbers, 4 numerical data points for Zoe. 55,000 because Zoe is a junior software engineer. 60,000 for the second year. For the third year, we're going to use 59,000. And for the fourth year of her work, we're going to give her $75,000. And I'm going to click Command Return to save this in my environment. Now, Cindy, there's a typo, should be Cindy with a dy underscore sal, reverse arrow, and the C function.
Cindy is a very, very senior manager of a software company, so she makes $200,000 in the first year, then she makes $250,000 in the second year, she makes $210,000 in the third year, and she makes $195,000 in the fourth year. And I'll click Command Return to save it in my environment. And the fourth vector for John, John underscore sal for salary, reverse arrow, and then the C function. And again, I'll use 4 numerical data points to represent his salary. 20,000, he's definitely network in the software service industry. 15,000, 40,000, and 60,000 for the fourth year. So I have 4 vectors for 4 of my roommates with 4 salaries for 4 years. As you guys can imagine, this will nicely fit into a matrix, but we'll talk about that later. For now, we agree that we have 4 distinct vectors that are numeric, and in these 4 vectors, I have one for Caroline, one for Zoe, one for Cindy, one for John. In those 4 vectors, I have numbers that represent their salaries for 4 consecutive years. As you can imagine, it would be extremely nice to have a date to represent when this salary was earned. So we will create a new vector called dates, reverse arrow, and the empty C function, and we'll simply give our 4 data points with dates that represent when these salaries were earned. And the first date will be 2009, 2010 for the second year, 2011 for the third year, and 2012 for the fourth year. This is an example where the date is a number, where it's numeric, and that's not quite what we want, correct? So what I can do to make the dates even better is create a new object, a new vector, with dates that have all the elements of a proper date, which means the month number, the day number, and the year number. So I'll create a new object called dates underscore full, reverse arrow, and provide number 12 for December 31st, 2009. And everything will be separated with a dash. Remember, it's the US convention where the month comes first, the date comes second, and the year comes third. Our second date will be December 31st, 2010. Our third date will be December 31st, 2011. That was a typo. And the fourth date will be December 31st, 2012. Now, this quite doesn't look just right because we can't just use this format. We'll need to make it a character first so that R reads this in. So I'm putting everything in double quotes because I want this to be a character. And once I have my double quotes, I can click Control Enter or Command Return and save this in my environment. What we have in our environment is a character vector, dates underscore full, with 4 elements. The dates here are characters, type character, but they do look like dates. They have the month, they have the day, and they have the year. What we have to do now is convert this to a date, to a data type date. To do that, we'll use the as.date function. We'll create a new object called dates underscore better, reverse arrow, as.date, uppercase D, very important. And here we are going to use dates underscore full as our input data, comma, and we'll need to provide the format in which our date comes in. As you can imagine, there are so many different date formats, like the European format, the South American format, the North American format. What comes first, day or month?
right? Back in Poland, we would say 15th of April, 2015. Here in the States, we say April 15, 2015, right? So there are different ways of expressing dates in different countries. We can also express the month using the 3-letter acronym, or we can spell out the month, or we can use the numerical representation of the month. So there are so many different ways of expressing dates, and I'm going to share the link to a cheat sheet on how to use these formats for dates in R. In our case, the format will be the following. I'm opening double quotes for my format, and I'm going to say this. %, month, dash, %, day, dash, %, uppercase Y. So my format is month, day, and year, full year, 4-digit year. If I use lowercase y, that would mean that my input data has only a 2-digit year, but in our case, we have the full year, 2009, 2010, 2011. So in our case, the format looks like this. And if I submit this, what I will get in my environment is a new object called dates_better, and the data type is date. 4 objects in a given format. And now R converted our character dates to date format dates. And now R understands these as dates. It's going to store the year first, then the month, then the day. Let's do a quick recap of what we have in our environment. In our environment, what we have is one vector that is a character type with names of my roommates. Carolina, Zoe, Cindy, and John. What we also have is salaries of all of my 4 roommates for the most recent 4 years, 2009, 2010, 2011, 2012. So we have 4 numerical vectors for each of my roommates: Zoe Sal, Carolina Sal, John Sal, and Cindy Sal, with 4 numbers each. And what we also have is 2 vectors with dates, right? One that is a character, because that's how the data came in, as a character, and one that is an actual date type that R understands as a date. Okay, so they have the same data, but with a different data type, and R will treat them differently. Okay, good. So now what I can do with these elements in my environment is I can try to build a matrix. Let's try to build a matrix with my roommates' salaries. So what I'm going to do is I'm going to create a matrix underscore salary. That's the name of my new matrix, and I'm going to use the matrix function that we have explored in the previous episodes. Matrix. And I'm going to combine all of my vectors into one mega vector, huge vector. I'm going to say C, and then Carolina underscore Sal, Zoe underscore Sal, Cindy underscore Sal, and John underscore Sal. Good, so I am combining all of my vectors together, okay, into one mega vector. And then what I'll do is I'll define the number of columns and the number of rows. So nCol will be equal 4, comma, nRow will be equal 4 as well. Beautiful. Okay, so I can submit my matrix function and build the new matrix. Let's do it. Let's do command return, control enter. And now I have a beautiful matrix that is, of course, numeric. 4 rows and 4 columns. If I double click on this, I'm going to get it right here. Okay, the first column is for my first roommate. The second column is for my second roommate, third column for the third roommate, and a fourth column for my fourth roommate. Good. Okay, and again, our matrix is numeric. Now, what's going to happen if I try to add the name of my roommate? Well, I could either try to add another row with the name so that we have each column quoted with the name of my roommate, right? Let's give that a try. If I try to add one more row to the matrix, let's see what's going to happen. All I have to do is create a new object called matrix underscore salary underscore new and use a function called rbind. The rbind function is going to bind their by rows, so bind by rows, stack them, union my objects. Rbind my matrix with my character vector with the names. And if I rbind matrix underscore salary with my names vector, what we will get is a new matrix called matrix salary underscore new. But look what happened. It converted the type of my matrix to character. Because I have added character data, it converted the entire type of my matrix to a character. So if there is only something of a character type in my object, the entire object gets the character type. So let's double click on this and let's take a look at it. Okay, so I have my numerical salaries in the first 4 rows, and the 5th row has names of my roommates. And this unfortunately became a character matrix. The entire thing was called character. Let's go back to our previous matrix, the one without the names at the bottom, called matrix underscore salary. It's the one with just the numerical salaries, and the entire matrix is numeric as well. Let's go back to this one. What if I were to improve this matrix? Because we saw an issue. When we added a character to it, the entire matrix became character, and all of my numbers in the matrix became character as well. So how do we solve this problem? Is there any other object that actually allows you to store multiple different data types? Yes, the answer is yes, it's a data frame. So let's convert this matrix underscore salary to a data frame. I'm going to create a new object called my underscore data underscore frame, reverse arrow, and I'm going to use the as.data.frame function to convert the matrix underscore salary to a data frame. And let's do control return, command enter. And I'm getting a data frame with 4 observations and 4 variables. If I click on the blue dot next to it, it's going to give me 4 variables, v1, v2, v3, v4, with numerical types in each of these columns. We call them variables, right? Each variable has its own unique data type. It doesn't have to be unique, own data type. Now, let's take a different example. What if I were to add dates to this data frame? What's going to happen? Is the entire data frame going to convert to character or to date? Right? Is the entire data frame going to change its data type? Or is the data frame more flexible? Let's check. If I actually reference the variable with the $sign, I can create a new variable very easily. What I'm going to say is I'm going to say my underscore data underscore frame $sign v5. I'm creating a new variable called v5, $sign referencing a variable name v5, and reverse arrow, and I'm going to use my dates underscore better vector. Okay, this vector represents the actual date at which the person made this amount of money. Okay, because I want to know when was the $101,000 made? When was the $55,000 made? When was the $200,000 made? Okay, so I'm going to create v5 with the dates. So let's run this. I made a typo. This should be dates underscore better. Okay. Aha, beautiful. So what happened is the initial 4 variables maintained its numeric type. They are still numeric. But I added one more variable called v5, and only this variable is a date type, as you can see. Okay, so let's double click on this, and that's exactly what I'm getting. 4 variables with salaries of my 4 roommates and the date at which it was earned. 2009, 2010, 2011, 2012. Last day of the year. Okay, so now I'm still missing one piece of information here. What I know so far is how much my roommates made for a given year, right? The new variable for a given year. But I'm still missing the name of my roommate. So I will rename my variables with the names of my roommates. Okay, and the last one will be called simply date. Let's do that. What I'm going to use now is a function called call names. Call names to rename my variables. Okay. Call names of my underscore data underscore frame. I'm calling my underscore data underscore frame object and using the call names function to change the call names for that object. Now I'm going to use the reverse arrow and simply use a combination of names and date. What will this resolve to? What would C names comma date resolve to? This will combine all the elements of my names vector, meaning Carolina, Zoe, Cindy, and John, with the date. So let's just highlight this and run this piece of code. Command Enter. In the console, I'm going to get the result of this. So I'm going to get 5 elements in this vector: Carolina, Zoe, Cindy, John, and date. And as you can see, this is the exact same order of my variables in the data frame. So now if I take this new vector with all my roommates' names and the date and put this in column names of my underscore data underscore frame. So if I run this piece of code, what happened in my environment is the names of my variables, v1, v2, v3, v4, v5, were converted to the names of my roommates and the date. So now this makes more business sense. Business sense because anyone else who is reading my data frame can easily understand whose salary this is for which date. And if I double click on this data frame to double check it, everything is clearly defined, clearly explained. I have my date for which this person made this much money in a given year.
Can I identify any numerical variables in my data frame? Maybe there are variables with characters, with strings. Maybe there are vectors with dates in my data frame.
But personally, I find these data types extremely useful when trying to understand the collection process behind my data set, how the data is being created. Also, for me, data types are very helpful when trying to understand what the different variables mean in my data frame. What's the story behind each variable? Why is it numeric? Why is it character? Why is it date? Maybe it should be a different type. Maybe I have to convert it.
The most basic data types are numeric, character, date. But there are also other data types that are commonly used. For example, a factor. A factor is a character that could be classified into groups. So if I have a variable with names of my classmates, and let's say I have 3 Johns and 2 Jennies, then the factor will classify Johns as one group and Jennies as the second group. So in my data, I will see a factor index, Johnny and Jenny, all right? And in my data, in my actual variable in the data frame, I will see 1, 1, 1, 2, 2. The 1, 1, 1 corresponds to Johnny, and the 2, 2 corresponds to Jenny. So in that way, R stores my character as a number in the variable. However, using the factor index, I can easily assign a group to the 1 and the 2. 1 stands for Johnny, in my case. 2 stands for Jenny. But my data is all numeric.
The factor. The factor appears very frequently when we load data from flat files like CSV, or we load data from an Excel file, XLSX or XLS, or simply have another database where the data types were not defined properly. R will read some of the characters that repeat constantly as a factor. What I want to do now is convert our character vector, the one with the names, to a factor and see how it looks like. And then we'll do the opposite. We'll convert the factor back to character to see how the entire loop works. So in the new line of code, I'm going to say my underscore factor underscore vector. And I'm going to use the as.factor function to convert the names vector to a factor. Command return. And in my environment, what I will see is my underscore factor underscore vector, so a new vector that is a factor type with 4 levels. So levels are the unique items in my vector, unique items. In my case, the unique item is Cindy, John, Carolina, Zoe. Okay. How does that translate in my data? If I actually were to print using the print function, if I were to print my underscore factor underscore vector, what I will get is this, something a little bit different. I will get a vector with my data, but I'm also going to get levels in alphabetical order. Cindy, John, Carolina, and Zoe. And what's going to happen here is whenever Cindy appears in my vector, it's going to put in a number 1. Whenever it sees John, it's going to put in number 2. Whenever it sees Carolina, it's going to put a number 3. Whenever it sees a Zoe, it's going to put a number 4. So this vector would be translated into 3, because Carolina is 3rd in the alphabetical order. 4, because Zoe is 4th in the alphabetical order, according to levels. 1, because Cindy is 1st in the alphabetical order. And 2, because John is 2nd in the alphabetical order, according to levels. And that's exactly what we see in our environment. In our environment, if we take a look at my factor vector, we have 4 levels, the ones that we just quoted, Cindy, John, Carolina, and Zoe, alphabetical order. And we have these numbers, 3, 4, 1, 2. 3 stands for Carolina, 4 stands for Zoe, 1 stands for Cindy, and 2 stands for John. So even though I have characters in my native data, in my raw data, they were converted into numbers that represent the alphabetical index of my unique values. Okay, so this is how data reads in very frequently from Excel, from CSV, from databases. Now, how do we convert this to something more easy to understand for us, which is character? Well, in a new line of code, I can convert my factors to a vector that is a character using the as.character function and using my underscore factor underscore vector object. Okay, and as you can see, it's a beautiful character vector. Now, if I save this in a new object called final underscore data, reverse arrow, and look at my environment, I will see that final underscore data is a character, not a factor anymore. It's a character that is easier for us to understand and read and analyze too.
Fortunately, in R, we can test our vectors, matrices, or variables in data frames for a given type using the is.something family of functions. For example, is.numeric will test if the vector is numeric. Is.character will test the vector and tell us whether it's numeric or not. The output of those functions are a logical operator, true or false. So we're asking R is.numeric a vector, and R will respond with true or false. What if we don't know the type of an object, and we don't know what is.function to provide? Well, then what we can do is use the type of function to get the type of our object without knowing or without even having a guesstimate of what the type could be. What is more, in R, we can change the type of our object using the as.type family of functions. As.numeric, as.character, as.date, as.logical. In my experience, the most common data type transformations are character to date, character to numeric, and factor to character. I'm really happy we know how to massage our data types. We are slowly but surely converting our data into something more meaningful, into something that we can analyze and do descriptive and predictive analysis on. So let's come back for the next episode. Thanks, guys. Bye-bye.